Okay, thanks for sticking around the whole day. I know it's been a long day of talks. Really awesome material. I learned a lot about React. I've been playing with React myself for about a year now. And this little thing here represents my first attempt at working with React. We tried to, we at RethinkDB, I'm one of the founders of Rethink. We've been building an open source database for the real-time web that helps you build real-time apps, connected devices, IoT, things like that. And we've been building it for the past 7 years. And we wanted to tackle a project that sort of helped us go full stack, all the way from hardware to the front end, because we see our users, building everything from, working with real-time connected devices in physical fields, out on farms, to people building real-time streaming apps using Twitter and Facebook feeds, things like that. So because we see so many different use cases, we wanted to play with a bit of hardware. So we built this little device. It's a little janky because I made it. But it's basically a real-time photo booth that allows us to track when people come into our office, they want to say hello, they could just press a button, take a photo with the photo booth, and to post it on Twitter in real time. And this was just kind of a pet project for me for a few weeks because I have not really done much with hardware in my life, and it was fun to be able to dig into it. So I want to talk about what I learned while building this, and talk about how some of the lessons that have been learned in React can be applied to both the front end and the back end. So as you start to build more complex real-time apps, you're going to have to think about how do I build the architectures? How do I actually let these different applications on the front end, on the back end, all talk to each other? And we're going to tackle what lessons we can learn, what patterns we can try to solve with some of this technology. Now I have 3 technologies I'm going to cover today: React, RethinkDB, and Raspberry Pis. So I'm going to move quickly. I have a tendency to speak quickly, so I hope you guys keep up with me. Okay, so what do I mean when I say a real-time app? It's important to start there because real-time has meant a lot of different things throughout history. What I mean is specifically, if everyone remembers the first time that they have played with Google Docs, you opened up a text editor, someone says, hey, check this thing out, and then once you start to use it, you start to see people typing in real time. And this is a really compelling experience. So for a lot of people, you probably remember this moment because it's the first time that your text editor started to inform you about other actions your users were taking. At this point, this seems like an old hat, with things like Draft.js and the fact that we're all building React apps. But when it first came out, it really showed the world that there was a different way of interacting with the apps that they were building, that you can feel like things are happening in real time, and you can get that user experience. Another example of this that's very popular is Slack. Who here uses Slack? Raise your hands. Right, so almost the whole room, we're all using it for React Rally itself. The reason that Slack is so compelling is not just that it has a great user experience or that it it's just chat, right? But the reason why it's so compelling is because it moves with you cross-platform as you're on your desktop, on web, on mobile. Today we have tools like React Native helping us solve these problems so that it's easy to build cross-platform apps that share a common code base. But these kinds of apps have pioneered this pattern, and what's magical is that even though it's just chat, it travels with you. So it doesn't matter where you are, you get channels and messages and notifications that are targeted to you, and it's doing that with thousands of users all connected in real time. These things are really hard to build. But before we can talk about why it's hard to build those kinds of things, we can start to play with just this thing that I built instead, this little janky little photo booth. And so what we're going to talk about is building real-time apps with these 3 technologies. This little guy, by the way, this is our friend, the Thinker. He is the mascot for the project. RethinkDB is a huge community, has north of 200,000 developers building with it today. It's the most popular document database on GitHub right now. The Thinker tries to show up without the documentation and interact with our users in lots of different ways. We have a full-time resident artist illustrator who spends time because we found that art is a vehicle for ideas, just like software is a vehicle for ideas. So you're going to see him pop up in a few more places. He's some call him a ghost. Some say he looks a bit like a tooth. But he's stuffed with creativity and about to be stuffed with Raspberry Pi. So. We work at RethinkDB. This is what our office looks like in Mountain View. That's our artist right there, front and center. You can see me with my bald head in the back. We wanted to build a device that actually be helpful for our office because why not? So our first thought was let's build a security camera, like a motion-activated security camera. We ultimately decided that was boring because honestly, no one's going to get to play with it. So instead, we have a lot of visitors who come to the office. We try to have a lot of fun. This is us designing the database. So we wanted to have this physical photo booth that people could check in with. I'm suffering from some internet concerns right now, but I'm going to show you on the big screen what it looks like. And so we have a lot of friends who come into the office. And we wanted to just sort of say, hey, I was at the Rethink office and take a photo with the Thinker. So we decided to build this real-time photo booth and play with some real-time technology. So we started with the Raspberry Pi. I'm sure, how many of you have actually used the Raspberry Pi? Okay, so a fair number of you. Nothing novel in this regard. It's a B+, costs 30 bucks. It's surprisingly capable because it has like half a gig of RAM and is able to be plugged into a bunch of common components. So if you just are getting up and running, it's a really nice way to get a stack that's easy to work with. RethinkDB can also be compiled for the Raspberry Pi architecture, so it was something that was fun for us to play with. You get this simple board that you plug things into. I use this display. It's a touchscreen display that Adafruit sells. I heard that you can get it a lot cheaper in Alibaba, but they sell it for a pretty reasonable number. I think it's $100 to $200 for the panel. And it's nice because you get an instant touchscreen that's like high fidelity that you can work with. For the front end, I decided to go with React because this is around the time that React first came out. I was still playing with it, and I wanted to think about some ideas that we've used in RethinkDB and see how they apply to React. So React, as you know, is a great library for building user interfaces. And the three things that really mattered to me when I looked at it, one is that it had components, building blocks for how you build your app, as I'm sure you all know, defining JavaScript and JSX, and they're either stateful or stateless. You're going to hear the topic of state come up a lot of times throughout this talk. State is your enemy as best as you can to avoid spreading state or sharing state. You want to keep it in one place. And React espouses this through the idea of unidirectional data flow, which we're going to return to in a minute. This is an example of the user interface for the photo booth. So you can see that we have a main component which just manages a real-time connection using socket.io to the back end, to the front end, and is a stateful component. Otherwise, we have our camera, which has two states, live and preview modes, and can switch into other modes to be able to tweet photos out. And then we have our film strip at the bottom, which is a stateless component that basically will just subscribe to changes from the back end and show photos as they pop in. Each photo is also a simple component. And React in general, correctly in my mind, encourages stateless components over stateful components. There's a lot of, that's a very simple way of approaching a very complex problem because you end up with lots of interesting component hierarchies, control components. There's a lot of issues around this. But a lot of the ideas that have become really popular in the React world, from things like Redux, Flux-style architectures, they all sort of emerge from the idea that you want to have one set of state that you pay attention to and have your UI reactively update itself in a stateless fashion. In reaction to things that are happening within your store. And so, and the third thing which is really great, as you guys know, is the virtual DOM. Really fast updates, not a lot of jQuery affecting the DOM tree. Very, very good. State changes will trigger these updates, and then we'll efficiently update all parts of the UI according to these diffs. Unidirectional data flow is, I think, one of the most powerful ideas that React has pushed forward. And the reason why is because once they started adopting it and people started to understand why it's so powerful, a lot of other front-end frameworks have adopted a similar approach. And what's great about it is you have one-way reactive data flow. You always know what the state of truth, what the state of your UI is, because you modify one state object and things will reactively flow in one direction only. This makes it really easy to think about state because you know it's in one spot, you know what it is, you have one source of truth. So that brings us to RethinkDB, which is the third part of this stack. And I'm going to show you the actual project in a moment. But to show you what we've got so far, and we'll play with it right now, we have a Raspberry Pi photo booth, which has a React front end, which encourages stateless components. Everything's in parallel. Lots of components are updating, all real time. A Node.js backend, very well suited for this because it has asynchronicity, because it is designed for lots of parallel operations. And RethinkDB as the underlying database because it has real-time push, because it is designed to have lots of parallelized operations happening concurrently. So to show you what it looks like, just to play with it, just going to switch over here. All right, so here we are. I have two apps on the side here. You can see that this is just basically the HQ behind the scenes. That's showing me all the photos as they're coming in, and I can manage them. But this is the front end that you see on this photo booth. And I'm just going to take a little selfie. All right, so we got our stamp, thinker stamp, and then we're going to tweet it out. OK, and there we go. And if we go to the Twitter feed, we have this feed, Thinker Booth, and we've got a new photo. There we go. All right, so I'm going to ask you guys in a minute. I'm going to give you a little address to go to take your own selfies. But for now, we're going to just jump back to this, and I want to talk about what is going on here. So basically, we've solved the problem of we have this front end that basically lets us take selfies, and we're running it from a backend, it's loading all the photos that have been taken in the past. But now we want to tweet the photos in real time, right? And we don't want, suppose that we had one photo booth, suppose we had 10 photo booths, or like 20 photo booths. To have each photo booth update on its own isn't really necessary, because then the photo booth has like a sense of state, like photos are stored on the thing, and whether they're tweeted or not, you might have them get out of sync, or you might miss some photos. So instead, we want to push it to a backend running in RethinkDB. And now we want to tweet these photos in real time and only have one tweet happen at a time. So we're going to have a service running, a microservice. It's basically going to watch for new photos as they come in and then tweet them out. And so if you look at the thing that I built here, this is the front end for the app on the left, and this is the front end for the app on the right. So this is like the thing this is what's actually going to tweet out the photos. The front end doesn't do any of that. It has no logic. It's just trying to take a photo and send it to the back end. So, now that we have these two services, the question is, we have these two real-time services, and how should they communicate? What's the best way for them to explain to each other when new photos come in? And this starts to approach like actual problems that people deal with when you want to build something like Slack or any more complex real-time app. There's a question of how do all these front ends, back ends, microservices, how are they all supposed to talk to each other? How are they supposed to exchange new information? How are they supposed to notify each other in real time as updates happen? This is a very complex issue because the way that people tend to solve it, you have your real-time web app on the left, your service is tweeting out photos, you want to build a mobile app now, and the question is to correlate changes. Most people would throw a message queue at the problem. They'd say, well, push a real-time feed running from one client to another client. And this is definitely possible, it's doable, but you end up with, as you can see from this architecture diagram, pretty complex infrastructure. And adding each new component to it is going to make things more and more complicated. So having all of these clients, all these connected clients talking to each other in this fashion is not going to be very scalable. And so, it's really cumbersome to keep track of updates if you have all these microservices trying to figure out what's changed constantly. So the way that people usually solve this is with polling. Polling is terrible because all you're going to do is just hit your back end repeatedly, or you're going to have to build lighter services that you can hit repeatedly to be able to identify changes as they come in. Ideally, you want the same thing that you get from unidirectional data flow. You want changes to push forward so that everyone gets updated exactly as it happens and no more than once. And if you want to add new real-time functionality to the stack, it's going to get even more complicated. So each new feature, each new service you build, it gets more and more difficult to figure out how to correlate all these changes, correlate all the updates. And there's a more subtle issue here for people who are building more focused systems, where if you have messages coming in, you have to figure out, do I want to route them to only one entity, like one channel? I have one channel open for my users. Every time a new message gets posted, do I just broadcast it to everybody? Do I figure out how to route them through this crazy infrastructure? So each time you add more complexity, more interconnected components, it becomes more and more complicated to figure out, how do I share changes across the entire stack? That brings us to RethinkDB. So RethinkDB is an open source database that makes it really easy to build real-time apps like this, or any other real-time app where you're trying to push changes from one client to another. It's a NoSQL database, so it uses a query language we built called REQL. It stores JSON documents, similar to MongoDB in that regard. And it's a distributed database that's easy to scale. So you can just literally throw nodes at it, and it'll be able to scale with your infrastructure. So when I say it's built for real-time apps, I have to explain what that actually means. So the key thing about RethinkDB that makes it different from every other database out there, and is how you can build these real-time apps really effortlessly and scale them really simply, is that it allows you to subscribe to change notifications on database queries. And what do I mean by that? So typically in a database, when you write a query, you wait for the response. And then if you want it to stay updated on the value, for example, we put a photo into the database. So we want to find out, do we have new photos? So normally you'd have to hit the database and pull it every few milliseconds to find the updates that are coming in. But in RethinkDB, you write your query, and then you can open a stream, and then get pushed updates as new documents come in that affect that query. So here you can just say, I want to take the table of photos and apply just .changes, which opens a stream, and now you have a stream of updates that will come all the way from the database and tell you, we have a new photo available for you to tweet, we have a new photo available for you to post in the film strip, and anything else that's subscribed to it will get affected. They don't have to know anything about each other, but they all will get updated at the same time. And so, because of this, you have no more polling throughout the whole system. You have changes that will push all the way from database to the front end of the UI stack. That's full real-time push all the way from the database all the way to your UI. And that's really beautiful. It means that you can scale it really easily because components through the top of the stack are stateless. You can just throw more pieces at it, and it'll just scale linearly. RethinkDB can handle upwards of 10 to 50,000 change streams, these change feeds we call them, per node, and you can scale it linearly from there. There are people running like 25 node clusters of Rethink for millions of users a day. So these change feeds are like the fundamental utility that lets you build scalable real-time apps. In this example of our photo booth, we have basically a real-time web app, a real-time web service, and if we wanted to build a mobile app someday, like to be able to take selfies on the go, you could just keep throwing more servers at this, and the only thing that they're going to talk to is RethinkDB. And because of that, they're more stateless, and you have unidirectional data flow. State of truth is stored in the database itself. That means you can scale it much more simply. And basically, change feeds enable a whole class of applications that were really challenging to build otherwise. So an example of this is a collaborative web and mobile app, because people are like exchanging photos with each other. Slack is another example of this. Multiplayer games are a huge area where we're seeing a lot of people build really amazing stuff with Rethink. Because people will have game worlds where there are lots of player events that are all affecting each other in real time. And then they'll maintain economies in parallel to it. And they can subscribe to updates happening in the economy and the game world and adjust like price in real time to be able to figure out as certain numbers hit certain thresholds, which is a very challenging problem if you didn't have real-time streams. Streaming analytics, if you want to track analytics in real time while you have transactions happening, you're able to open these streams in parallel and build like UIs, like React dashboards for all sorts of like statistics and benchmark some of the transactions that are happening as is happening within like milliseconds. Marketplaces are a huge area for this if people are building like ad exchanges or any kind of economy where people are sharing things, and there are lots of events that are happening where the data, where its value is transient, and if you act on it in the moment, you can derive great value. So if you can determine what's happening within milliseconds of an action and respond to it, marketplaces are a huge area for this because people are dealing with economies of scale. And connected devices, which is probably my favorite. This is a really simple example. But the coolest example of this, absolutely my favorite hands down, is that I found out a few months ago that NASA is running RethinkDB because when people take EVAs on spacewalks, there's a chance that their hose in their suit can malfunction and start to fill the suit with liquid. So there's a new nightmare for you, is that you can drown in space. And so they have all these metrics coming in from sensors on their suits, and they can process all that data in real time and then respond to situations and be able to do analytics and real-time analytics on the suits to make sure the astronauts are safe. And so that's like, to me, the coolest case, because space, But there are lots of people building cool things with like farms where you're able to do like variable fertilization and respond to lots of real-time updates that are coming from all the connected devices you have, and figure out that now is the ideal time to like plant your crops and to use this like fertilization rate. So there's like a lot of really interesting use cases with IoT. I think we're just starting to see it. The key difference is that with this kind of system, you don't just subscribe to updates on the data, you subscribe to updates on the meaning of the data. So just very quickly, I'm going to power through this because we need this information to show you some cool stuff. Querying RethinkDB looks very simple. You have a chainable API. So in this case, we are accessing a database table. It looks just like JavaScript because it is just JavaScript. We're going to pluck the last name to isolate a document property. We're going to consolidate all duplicate values with distinct. And then we're going to count the number of items with count. And so basically, if you notice this, it looked like JavaScript. It's not like SQL or some string that you convert into a query language. It's just JavaScript. And that's because RethinkDB embeds natively into whatever program language you use. JavaScript, Python, Ruby, and Java are the official drivers. But name a language, Go, Haskell, Erlang, there's a driver for it. So these queries, basically, you chain them out, then they get efficiently sent to the server and executed and distributed in a distributed fashion. So basically, if you do like a MapReduce query, it doesn't happen on the client, it'll get sent out to the cluster, and the query will go to each node and to each document and ripple back up. And so, what's nice about this is you get like your native debugging tools. You get to work with an environment where you have to do context switches. It kind of feels a lot like you're just manipulating data client side, but because of just a little bit of magic it's doing, everything's happening on the back end. And the query language is pretty rich. You can throw change feeds on most of these queries, and more of them are being added each release. So you have control flow, things like branching, looping, grouping, MapReduce, distributed joins. It's really a programmable language that masquerades as a query language. And the nice thing about this is that we're having an upcoming release. We're going to be able to do streams, change feeds on joins, which is magical because you can join documents on the back end and then receive updates that are going to be streaming to the front end. So in this example, very simply, of a change feed, we have our query. We tack on .changes, and then we get back documents that will notify additions, modifications, and removals. So if you guys want to pull out your laptops, This might destroy the server that I'm running because there are a lot of people in this room right now. I'm taking a lot of risks here, so just bear with me. But if you go to this URL, I'm just going to pop up this right now so we can see the updates you guys are sending in. But make sure that you go to, it's https://photobooth.ngrok.io. And I used ngrok for this because I discovered that when you're using a webcam, recent versions of Chrome will disable it if you don't serve it via HTTPS, which is a new feature they added a little while ago. I guess for security, I mean, it makes sense. But because I didn't set it up, I'm using ngrok to just do forwarding. If you guys don't know about ngrok, it's a really handy tool to create tunnels very quickly. So it's very important to use HTTPS because otherwise you will not be able to submit photos. So basically, at this point, we're going to see people hopefully start to submit photos. And what I'm going to open in parallel to this is I'm going to open the backend. So each RethinkDB instance basically has a dashboard that you get that allows you to see the activity happening within the cluster. And you can see that people are requesting photos from the backend. And we're just going to pop over, while people are doing this, we're going to pop over to the Data Explorer because I want to show you just a little bit of what's actually going on under the hood. So in this case, I'm going to just take a look at our photos. Let's see here. All right, so I'm just going to load up a query I had previously to take a look at the table of photos. And then we're going to run this query. Give me a second here. I think we're hammering our server pretty hard right now. All right, let's see what we can do here instead. You guys took it down. That was fast. All right, so what I'm going to do, let's see here. OK, let's see. Really great photos. Yeah, OK, so what I'm going to do is I'm just going to pop this up locally so you guys can see what's going on. OK, I guess we're locked out. OK, so I'm going to talk instead about what it feels like to work with these change feeds. So basically, when you're in the Data Explorer, if I had a working droplet right now, when you're in the Data Explorer, you're able to work with these change feeds from the Data Explorer. And as you write out your query and subscribe to feeds, you'll see a little document that will pop up in your database. And it's going to notify you with a little JSON string about any properties that were added, removed, modified, and the values of those properties as well. And what you can do is you can basically take these change events and you can subscribe to them and you can consume them from your front end. To show you what that looks like in the code, because at least that I can show you, you're going to get this JSON document in the client and you're going to apply that diff to the front end manually. Here we go. OK. So as an example of this, so this is in the front end. All we do to subscribe to a change feed is back end. OK, so here we go. View, let's do. OK, so in this case, basically, we're given a promise that we're gonna yield, and what we get is a table where we subscribe to changes without the property image, because we don't want to have the binary data, because image is a property which stores the binary data on the photo. So we're just going to take each JSON document without the image property, and we're going to subscribe to it and then say for each time we have an item where we have a new value in the item, when this property new val is present in your JSON document, you're going to basically see, you're going to know that it's a new value. If new value is null, it means the document was deleted. If old val is null, it means the document is a new document. So in this case, we're determining whether we've added or removed the specific document, and we're just going to use socket.io to emit that little update from the back end to the front end. So what we're using is basically a change feed that's subscribed from the RethinkDB cluster, and then we have a Node.js app which takes that change feed, then passes it up using socket.io, the direct JSON document, and then it's applied in the front end. And from that, you have unidirectional data flow that stretches all the way from the database to the UI. So the implications of this are, if you want to look at the code, by the way, yourselves, you can go to this repo, RethinkDB/RethinkDB-photo booth. If you set it up on your local machine, you can sort of play and tug on all the pieces and see how they're all related. So basically, in this example, again, we have a couple services that are running side by side, and you're able to have events all subscribed and updated in real time, except that the cluster itself is the only thing that's managing all those updates. So basically, just to sum up some of the ideas that I want to propose here that I think are interesting from the React world that have been very applicable when we're examining how people build real-time apps for RethinkDB architectures, is that if you're polling for data anywhere, you should try to figure out how to not do that. You should try to figure out how to use a push-driven architecture instead. That's going to be the most expensive thing as you start to scale and as components get more interconnected. The push access model simplifies building these real-time architectures. It makes it very easy to be able to send an update from any part of the stack to any other part of the stack. One source of truth makes it easy to manage state. The only counterpoint to this is people sometimes will ask me, what if I'm running multiple databases? Because in this example, the database has all the information it needs, and it pushes all the information up to the rest of the architecture. If you're running multiple databases, I would urge you to look at something like event sourcing, which is a really great model. We're able to tag each document with a unique timestamp that you're able to then track it through the system. And you can use that with something like Rethink very simply, pair it with something like Kafka to be able to shuttle those changes around. But fundamentally, having one source of truth, having one primary data store is the best possible option because it makes it easy to figure out what's happening throughout the whole system. And RethinkDB is the first database for the real-time web, the first database that does this inversion of the query access pattern from subscriptions, from polling to subscriptions. We're able to have changes that push through the whole architecture. And we've already seen more databases start to emerge with it. I think we just saw in Oracle, in the most recent version, they started to add something that looks a little bit like this as well. And a lot of other databases are starting to look at ways to integrate this. So we're going to see this idea, I think, start to push in more environments. If you're curious about Rethink, you can join the Slack community. We're well known to have one of the friendliest open source communities out there. We also have just launched a new project a few months ago that might be worth checking out if you find a lot of this talk about how do I build a real-time app interesting. Horizon is a new project that's based on the entire Rethink stack. When I built this app, I had to use things like socket.io. I had to use a bunch of components to be able to maintain which data components are being updated, to do authentication, to do access control to data, things like that. And so Horizon tries to take that entire JavaScript stack of building apps and simplify it so you have just a canonical open source backend that you can install with just one command and then have an entire full stack running from database all the way to the browser. It allows you to basically start writing your React app in your browser and then extend it on the backend and then move all the way to the database when you're ready to do so. And it hides those details from you until you're ready to work with it. Includes a lot of useful libraries for things like access control, authentication, identity user management. The goal being basically to try to make building JavaScript apps simpler. And it kind of captures a lot of the ideas that I've been talking about now, but in a standard toolkit. We just released a new version today, version 2.0, so there's a blog post that you should go check out if this sounds interesting. Horizon makes it simple to quickly prototype your app and then scale it to millions of users. I can show you some demos of this afterwards if you're curious and want to come up and play with it. So you can check out Horizon at horizon.io. That's the newest project from the RethinkDB team. But in terms of Rethink, if what I described sounds interesting to you, if you have more questions about it, come find me later. You also can go check out the docs, which have a lot of information about how to work with it, how to get up and running in 10 minutes, and just follow us on Twitter. So I want to thank you for your time, and we're all ready to go and celebrate for the end of the day. So come back for tomorrow for day 2, and thanks a lot. Appreciate it.